Good morning, guys. Today we're going to look at SPI 5.4. That's normal distributions. Normal distributions just deals with a different type of probability, or taking a big group and figuring out what percentage of that group fits into different categories. So let's look at these first couple of examples, and it's just going to really be about identifying the wording that tells us it's a normal distribution problem. So first example, the shelf life of a packaged food follows a normal distribution. So there it is, with a mean of 23 days and a standard deviation of 1.5 days. To the nearest hundredth, what's the probability the packaged food will last for more than 20 days? Well, as soon as I see normal distribution, I'm going to grab the calculator, because it automatically becomes a calculator problem at that point, and there's something specific I've got to go find. Right here above vars, which stands for variables, we see DISTR. This is distributions. So we're going to hit second, distributions, and first two choices are normal PDF and normal CDF. So here are the normal distributions we want. We always want normal CDF because we're always going to be adding up a group of normal distributions. So always CDF for cumulative distributions. So hit enter. So there's my normal CDF. Now what do I plug in there after normal CDF? I'm going to plug in LUMS. You want to remember LUMS, L-U-M-S, LUMS. And what that stands for is lower, upper, mean, and standard deviation. So from the problem, we need to identify the lower end, the upper end, the mean, and the standard deviation. The calculator will do all the percentages and probabilities after that. So let's look at what we've got. Normal CDF, the lower end. Well, what's the problem asking? It's asking us to find more than 20 days. So if we want more than 20, 20's got to be the low end. Okay? And we need the upper end. Pick some outrageous number for the upper end. Okay? Something like 1 million. So from 20 days all the way to 1 million days. So we're going to put 1 million in there. Doesn't matter, just something outrageously large because we want to calculate all the way up there. Then we want the mean. Well, we see right here the mean was 23 days, so we plug in 23. Then we need S, standard deviation. Standard deviation was 1.5 days. So 1.5. And it's really as simple as typing that into the calculator. So 20, comma 1 million, comma 23, comma 1.5. Close it off. 97.72%, which is 98%. It's pretty straightforward. Now, I mean, as you can see, this upper end, I could put it at 2 million. And it's not going to change that percentage at all. Okay? I could have put it at 9 million. Still not going to change that percentage at all. I could have made it a little bit smaller. I could have done it at 100,000. Didn't change that percentage. So just pick something outrageously large. It doesn't matter how big it is. You're going to keep getting the same percentage again and again and again, no matter what. So 1 million is always really good for an upper end that you don't need. You don't really know exactly how far you're supposed to go. Let's look at the next example. 300 people are surveyed about the time they spend exercising each day. Based on the results, the time they spend follows a normal distribution. So there it is again, normal distribution. So I'm going to go ahead and grab it. Second distribution, normal CDF. With a mean of 40 minutes and a standard deviation of 5.5 minutes. About how many people spend 40 minutes to 51 minutes exercising each day. So normal distribution tells me I need normal CDF with LUMS filled in. So let's start filling them in. I need my lower end. Well, what are we trying to find? How many people go from 40 minutes to 51 minutes? Well, that's actually my lower end and my upper end. They gave me the boundaries on this one. Instead of saying more than 40, which would be like 40 to 1 million, or less than 51, which would have been like 0 to 51, they put the boundaries on there, 40 minutes to 51 minutes. So there's my lower end and my upper end. Now we just need to finish plugging in mean. Mean is 40 minutes. Standard deviation. Standard deviation is 5.5 minutes. And we calculate. So normal CDF, 40 to 51, with a mean of 40 and a standard deviation of 5.1. Close it off. Oh, sorry. Standard deviation of 5.5. And I get 47.725%. So 0.47725. Now notice this doesn't match any of my answers. Well, that's because they didn't ask for the percentage of people that exercised for that long, or what probability a person exercised. They asked specifically for how many people exercised. So this is the other way they can ask a normal distribution problem, where they want us to do something with that percentage. Well, it all goes back to how many people we started with. We have 300 people starting out. Well, we know 47% of them exercised 40 to 51 minutes. So it's as easy as taking that 47%, multiplying it by 300, and we get 143.175 people, which is choice B, 143 people. So there's the two types of normal distribution problems that you'll have to deal with. One, they ask, here's a normal distribution, we normal CDF, lums it, and we get the percentage or probability, and that's all they ask. What's the percentage or what's the probability? The other one is how many of the group of the normal distribution. So in that case, you want to still do normal CDF with a lums to get your percentage. You then have to multiply that percentage by the total group to get the answer. Calculator is going to do all the work. You just have to organize all the information and look for that keyword of normal distribution and the other ones of mean and standard deviation, and make sure you're getting your lower and upper ends correct. That's it for normal distributions, and I'll see you in class tomorrow, guys.